Hello everyone, welcome to the solution of LeetCode problem 202 named happy number. In this problem, we have to write an algorithm to determine if a number n is happy. So here, the definition of the happy number is, a happy number is a number defined by the following process. Here, it starts with any positive integers and replace the number by the sum of the square of its digits. Now, repeat the process until the number equal 1 or loop endlessly in a cycle which does not include 1. Now, those numbers for which this process ends in 1 are happy. Now, we have to return true if a number is happy, otherwise we have to return false. Now, suppose the n is 19. So here, in the first iteration, 1 square plus 9 square is 82. Then in the second iteration, 8 square plus 2 square is 68. In the third iteration, 6 square plus 8 square is 100. In the fourth iteration, 1 square plus 0 square plus 0 square is 1. So here we can see that 19 will end up becoming 1. So 19 is a happy number. But for the number 2, it is not possible to be happy. So here we have to return false. Now the constraint are, the value of n can be in between 1 to 2 to the power 31 minus 1. I hope you understood the constraint. Now let's move on to the algorithm. Now we can solve this problem in many approaches, but I am using the simpler one, which is the simple simulation. So here, suppose we are given a number of n. Suppose the value of n is 19. Now, in the first iteration, we have to replace 19 with 1 square plus 9 square. That means 82. Okay, so far so good. Now, in the second iteration, we have to replace 82 with 8 square plus 2 square, which is 68. Now, in the second iteration, we have to replace 68 with 6 square plus 8 square, which is 100. Now, in the fourth iteration, we have to replace 100 with 1 square plus 0 square plus 0 square, which is 1. Okay, so here, if we run this simulation, we have seen that we have concluded with the value 1. So here we can see that 19 is the happy number. But wait, suppose we are given a number, suppose the value is x. This is a random number. Now, in the first iteration, x become a. In the second iteration, it become b. In the third iteration, suppose it becomes c. Okay. Now, in the fourth iteration, suppose it become d. And if in the fifth iteration or in any of the iteration, it become b again. But wait, suppose the value of b is 10 and we have found 10 in any of the iteration, but after the d step, we have found another 10 here. So here, d will be referenced back to the element 10. So we have found a loop. Here, this loop cannot be stopped because it is the infinite loop. So here we have to check one more thing, and in each of the iteration, we have to check whether the corresponding value we have found after squaring the summation, this, and this, so on, we have to check whether this value appears previously in any iteration or not. If any of the summation value appears previously in any of the iteration, that means it will become an infinite loop. So here, in those kind of cases, we have to return false. Otherwise, if we can make the input element n 1, then we have to return true. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function, name is happy, which has a parameter n, and it will check whether a given n is happy number or not. Now, to check the repetitive value, we have taken the set. Now we have to run a loop while n not is equal to 1. Now here inside this loop, we have taken two variables, which is sum and current. And here, by using this loop, we have to take the summation of all of the squares of the digits, and we have to check whether this summations appears before or not. If it appears before, that means it will become an infinite loop, so we have to return false. Otherwise, we have to simply add this summation into the set and replace the value of n with the summation. Finally, we have to return true. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.